Hello friends, welcome back to our channel. Today, we are going to take you on a journey through time to the very beginning. We will explore how our solar system came into existence, starting from the moment when a huge cloud of gas and dust collapsed and formed the sun. Let's go. First, let's look at the universe as a whole. After the Big Bang, the universe was a hot and dense soup of elementary particles. Over billions of years, these particles cooled and combined to form atoms, mostly hydrogen and helium. These atoms then gathered together to form the first stars and galaxies. One of these stars would eventually become our sun. About 4.6 billion years ago, long before Earth and its inhabitants existed, our solar system was just a giant cloud of gas and dust floating around in space. This cloud was known as a solar nebula, and it contained mostly hydrogen and helium, the two lightest and most abundant elements in the universe. However, it also contained heavier elements such as oxygen, carbon, and iron, which are essential for life as we know it. These elements were produced by previous generations of stars that had lived and died in the galaxy. The solar nebula was not uniform but had some regions that were slightly denser than others. These denser regions acted as seeds for the eventual formation of planets and other objects in the solar system. It's important to note that while our solar system was forming, the Earth, the Moon, the planets, the Sun, and everything else we see today did not exist yet. Scientists believe that the formation of our solar system began when a large shockwave from a nearby supernova explosion hit the solar nebula. This shockwave caused the cloud to collapse in on itself, pulling matter towards the center. As the cloud collapsed, it began to spin faster and faster, much like a figure skater pulling their arms in to make their body rotate faster. The spinning motion caused the cloud to flatten into a disc shape with a bulge in the middle. In the center of this disc, the pressure and temperature were high enough to cause nuclear fusion to occur, creating the sun. As the sun formed, it released a tremendous amount of energy that pushed away the surrounding gas and dust, clearing a path for the planets to form. The remaining gas and dust in the disk began to clump together into small bodies called planetesimals. These planetesimals ranged in size from kilometers to tens of meters across. The planetesimals formed through a process known as accretion, in which small bodies come together and stick to form larger bodies. As the planetesimals grew in size, they began to attract more and more gas and dust, eventually forming protoplanets. These protoplanets continued to grow until they reached a size where their gravitational pull was strong enough to clear the remaining gas and dust from their orbit. At this point, they became full-fledged planets. Closer to the sun, where temperatures were higher, only rocky materials such as silicate minerals and metals could condense and solidify. This is why the planets closest to the sun, Mercury, Venus, Earth, and Mars, are small, dense, and rocky. Further out in the solar system, where temperatures were cooler, volatile substances such as water, methane, and ammonia could also condense. This is why the planets farther from the Sun, Jupiter, Saturn, Neptune, and Uranus, are much larger and have more massive atmospheres. Earth's formation is particularly interesting because it was here that conditions were just right for life to emerge. Early Earth was a hot, molten mass, constantly bombarded by asteroids and other debris from the solar system's formation. Over time, the planet cooled and a solid crust formed. Oceans formed as water vapor in the atmosphere condensed. And over billions of years, life arose in the oceans and eventually moved on to land. It's important to note that the formation of the solar system was a chaotic process. There were many close calls where Earth could have been knocked out of its orbit or destroyed by an asteroid impact. But somehow our planet survived and became the home of life as we know it. Now let's fast forward to the present day. Our solar system consists of 8 planets, including Earth, revolving around a central sun. Each planet is unique and has its own characteristics. Some planets have rings, others have dozens of moons, and some have extreme temperatures and atmospheres. The Sun, which makes up 99% of the mass in the solar system, is a yellow dwarf star. It's incredibly massive, with a diameter 109 times larger than Earth. The Sun provides light and heat to the planets and is the center of the solar system. Mercury is the smallest planet, the closest to the Sun. It has no moons and its surface is heavily cratered due to collisions with asteroids. Venus is similar in size to Earth and is the hottest planet in the solar system, despite not being the closest to the sun. Its thick atmosphere traps heat and it rotates in the opposite direction to most planets. Earth is the only planet known to support life, has a diverse range of ecosystems, and its atmosphere and liquid water are essential for life as we know it. Mars is a cold and dry planet with a thin atmosphere. It has 2 moons, and its surface is covered in red rust due to the high amounts of iron oxide. Jupiter is the largest planet in the solar system and has more than 75 known moons. It's a gas giant with a great red spot, a massive storm that has been raging for centuries. Saturn is another gas giant and is known for its beautiful rings. It has more than a dozen known moons, and its atmosphere has a hexagonal shape at its poles. Neptune is an ice giant with a blue color due to the methane in its atmosphere. It has 14 known moons, and its discovery in 1846 was the first planet predicted by mathematical calculations rather than observation. Uranus is another ice giant and is tilted on its side, which may have been the result of a collision with another planet. It has 15 known moons, and its discovery in 1781 was the first planet discovered with a telescope. In addition to the planets, the solar system also contains other objects, such as asteroids, comets, and Kuiper belt objects. Asteroids are rocky bodies that orbit the Sun, mostly found between Mars and Jupiter. Comets are icy bodies that travel in highly elliptical orbits and can have tails that extend for millions of kilometers. Kuiper belt objects are icy bodies that orbit the Sun beyond the orbit of Neptune and include dwarf planets such as Pluto. The formation of our solar system is a remarkable feat of nature and the result of billions of years of evolution. From the initial collapse of a cloud of gas and dust to the formation of planets and other objects, each step in the process was finely tuned for life to flourish on Earth. Studying the formation of our solar system helps us understand our place in the universe and appreciate the incredible forces that shaped our world. As we continue to explore the solar system and beyond, we may discover new worlds and new forms of life that remind us that we are all connected by the same forces that govern the universe. Thank you for joining us on this journey to the beginning of our solar system. If you enjoyed this video, please give us a thumbs up and don't forget to subscribe to our channel for more exciting videos about space and the universe. We have many more videos for you to watch and learn. See you next time.